Welcome back to LINGA Code Technologies.
Thanks for having me.
Today we're diving deep into something really crucial, right? Where artificial intelligence and security kind of collide. Agentic AI, threats and mitigations.
Right.
And, this is part of our listening series.
Hmm.
And as we've said before, it's not just about like passively hearing cybersecurity updates. It's about really, truly listening, like understanding how threats are changing, how AI is reshaping security, what it all means, for you.
Absolutely.
Just like how real listening needs us to be aware, right? Cybersecurity, strong cybersecurity demands foresight, not just reaction.
Right.
And that's something we really focus on cultivating here at LingaCode with that intention of raising awareness about all of this.
Yeah.
So you recently shared with us a really, really foundational document from the OWASP Agentic Security Initiative.
Okay.
It's titled Agentic AI Threats and Mitigations.
Mm-hmm.
And this version 1.0 report, dated February 2025, also serves as the OWASP Top 10 for LLM Apps Gen AI Agentic Security Initiative. Quite a mouthful.
It is, yeah.
But a lot of crucial information in there.
Yeah.
And it's important to keep in mind, as the document itself clearly states, that the information we're about to discuss today is just for general information.
Right.
Not legal advice.
Yeah.
And it also includes links to other websites for convenience. But that doesn't mean that WASP is responsible or endorsing, what's on those sites.
Right.
So, standard disclaimers. This work is shared under a Creative Commons CC BY-SA 4.0 license, which means you can share it, adapt it, as long as you give proper credit. Mention the project, mention the specific document, you know the drill.
Yeah.
So our goal for this deep dive is to really, truly dig into this report and pull out the most important insights for you, the listener.
Yeah.
Whether you're building agentic applications or you're securing them, whether you're a developer, an architect, a platform engineer, a QA engineer, security professional. We want to give you a practical, actionable understanding of what these new threats that come along with agentic AI are and how to deal with them.
Mm-hmm.
So let's unpack those, right?
Right.
The report really points out that, agentic AI is not a brand new concept.
It's not a new idea.
But it has been significantly amplified by the power of large language models, LLMs,
Right.
and generative AI.
Yep.
This has expanded what these systems can do and, of course, expanded the risks that are involved.
Yeah.
So today we're going to touch on the core ideas behind agentic AI, look at a typical architecture, discuss the threat model that's being proposed, highlight some of the key ways to mitigate these risks.
Mm-hmm.
So to start us off, what exactly are these AI agents we're talking about? Because it seems like they're more than just your average AI, right?
Yeah, I think the document does a good job of explaining that.
Okay.
So it starts by defining an AI agent as, like you said, it's not your average AI.
Right.
It's a piece of software, an intelligent piece of software
Mm-hmm.
that can observe its surroundings, think about what it's seeing, make decisions, and then act independently to achieve specific goals.
Right.
And it even refers back to, artificial intelligence, a modern approach.
The classic textbook.
Yeah, by Russell and Norvig,
Mm-hmm.
which emphasizes that a truly intelligent agent doesn't just react.
It doesn't just sit there.
No, it acts appropriately for its circumstances.
Mm-hmm.
It can adapt to new situations. It learns from what it experiences, makes sensible choices, within the limits of what it can do.
Right. So it's not just about generating text or images like we might see with, a more standard LLM.
Exactly, yeah.
There's this added layer of being able to take independent action in the world.
That's right.
And while, the idea of AI agents has been around in research for a while, it sounds like LLMs have really given them like this massive boost in capability.
Yeah, I think that's a fair assessment. While earlier forms of machine learning, like reinforcement learning, have definitely contributed to the development of agentic AI. The sophistication, natural language understanding, the sheer scale of knowledge, general flexibility of LLMs have been a game changer.
Right.
Really made it possible to build much more capable agents, which leads to a lot more interest in their real-world applications.
Makes sense.
In fact, the document mentions this forecast from Gartner that by 2028, a significant portion, around a third, of enterprise software applications will be incorporating agentic AI.
Wow.
That really highlights how relevant this topic is becoming.
That's a pretty huge shift in the landscape.
Yeah.
So what are some of the core abilities that really define these advanced AI agents? Like what makes them so much more capable now?
So the report outlines several key capabilities.
Okay.
The first is planning and reasoning.
Right.
These agents can figure out the sequence of steps needed to reach their objective,
Mm-hmm.
develop an action plan, even adjust that plan as things change.
Wow.
They often use LLMs as the core of their, I guess you could call it a reasoning engine,
Okay.
essentially controlling how the application flows.
Okay.
A really important concept here is the REACT pattern,
Okay.
which stands for reason plus act.
Okay. Reason plus act.
Yeah, where the agent alternates between thinking and taking action.
So instead of just responding to a direct instruction, the AI is actually thinking ahead. It's strategizing.
That's right.
What other key capabilities are there?
Well, LLMs enable some really sophisticated reasoning strategies as well.
Okay.
So the document talks about reflection, where an agent can look back at what it's done, try to improve
Mm-hmm.
how it operates in the future. A key part of this is what's called self-critic,
Mm-hmm.
where the agent actually evaluates its own thinking and actions to try and identify flaws.
Right.
Then there's chain of thought, where complex problems are broken down into a series of logical steps,
Okay.
sometimes without any human intervention in between. And finally, there's sub-goal decomposition, which is basically the idea of taking a large, complicated goal and breaking it down into smaller, more manageable tasks.
Right. So tackle a big problem by breaking it down.
Exactly.
What else is fundamental to how these agents work?
Well, another really crucial aspect is memory, which is often called statefulness.
Okay.
So agents need to be able to retain information,
Mm-hmm.
both in the short term, within a single interaction or a session, and also in the long term, across multiple interactions.
Okay.
This memory can include the reasons behind their actions,
Right.
what tools they've used, any information they've gathered,
Okay.
and then, of course, there's action and tool use. Agents can actually do things in the real world.
They don't just think.
No. They can interact with other systems through built-in functions,
Mm-hmm.
local tools that are part of the application,
Okay.
external APIs. The document specifically highlights LLM function, calling as a specialized way of using tools.
Interesting.
And it even provides links to resources from OpenAI, Hugging Face, LangChain, a Medium article if you want to explore that in more detail.
Excellent.
Think of function calling like the AI agent having a specific set of skills or tools that it can use to accomplish tasks.
Right.
So things like sending an email, querying a database.
So it sounds like these agents are becoming deeply integrated with all sorts of other systems and services.
That's right.
Okay.
And the document helps clarify how agents relate to just your regular LLM applications.
Okay.
So it points out that LLM applications can, in fact, exhibit agency,
Right.
show some level of autonomous decision-making and action.
Right.
Conversely, agents can be built as LLM applications by using various development frameworks.
Okay.
So these frameworks like LangChain, LangFlow, AutoGen, Crew AI are designed to make it easier for developers to actually build agentic capabilities into their software.
Interesting.
OWASP SI is even planning a more comprehensive guide to these frameworks in their upcoming Agentic AI landscape.
That sounds useful for developers and for those who are more, hands-on and want to see these concepts in action.
So the report mentions that the OWASP ASI GitHub repository actually includes practical examples of LLM agents that have been built using these popular frameworks.
Okay.
And what's interesting, particularly useful for understanding the risks, is that some of these agents are intentionally designed with vulnerabilities.
Oh.
So this lets developers and security professionals see firsthand how these flaws can be exploited, but also to understand how the agents themselves function.
Makes sense.
And finally, the document touches on the different levels of autonomy that agents can have, how they're orchestrated.
Right.
This can range from very rigid, hard-coded workflows, where the agent's actions are highly controlled, to fully conversational agents, where decisions are driven almost entirely by the interactions with the user and the model's own reasoning.
Got it.
So there's a spectrum.
Okay, so we're starting to get a much clearer picture of what Agentic AI is, what it can do.
Yeah.
Now let's move on to how these capabilities are structured.
Okay.
The document mentions a reference architecture.
It does.
So what does a typical Agentic AI system look like under the hood?
So the document includes what it calls a single agent architecture diagram,
Okay.
although it's not described visually in the text itself.
Right.
But its main purpose is to highlight these key components that would typically be deployed
Okay.
and that are important to consider, when we're thinking about potential threats.
Okay.
So these core deployable components include the main application itself, which has the agentic functionality embedded within it to help users with their tasks, often in a way that extends beyond just a single session.
Okay.
And then you have the agent itself, which is the part that takes natural language input, text, and sometimes even other media.
Okay.
And it likely uses one of those agentic frameworks we discussed to manage its operations.
And the core intelligence, the LLM itself.
Exactly. You'll have one or more LLM models, which could be running on local infrastructure or accessed remotely via an API.
Hmm.
And these are responsible for that reasoning and decision-making aspect of the agent.
Okay.
And then you have all the various services that the agent can interact as.
Right.
And this includes functions that are built directly into the application, local tools, pieces of code the agent can execute, external services that it can call through APIs.
Mm-hmm.
These interactions with services often happen through a mechanism called function calling, or sometimes through a more general tools interface,
Okay.
or even through code that the LLM itself generates and then executes.
Interesting.
Because these connections to other services are so critical, they represent potential pathways for attackers to exploit vulnerabilities.
It sounds like there are a lot of different moving parts
There are.
in an agentic system,
Mm-hmm.
and each one could potentially be, a point of vulnerability.
That's right.
Right.
You're absolutely right.
Okay.
The architecture also includes what are called supporting services.
Okay.
And these are things like external storage systems, used for the agent's long-term memory,
Mm-hmm.
vector databases that are often used in RAG, retrieval augmented generation,
Right.
to provide the agent with relevant information,
Okay.
and other external data sources that the agent might need to consult.
Okay.
And while RAG can be thought of as a type of tool use, the document highlights it separately because it's such a common and important component in many LLM-powered applications.
Right.
And it's worth noting that those data sources used in RAG can also be targets for manipulation, potentially leading the agent astray with poisoned information.
That's RAG. So that's for a single agent. What happens when you have multiple agents working together? How does that change things, from a structural perspective?
So the document then introduces the concept of multi-agent architectures,
Mm-hmm.
and these involve having multiple independent agents that can operate in parallel,
Okay.
or that have very specific specialized roles to play.
Right.
So in these more complex systems, you have communication happening between the different agents,
Right.
and sometimes there's even a coordinating agent that oversees the activities of the others, kind of helps to orchestrate the overall workflow.
Okay.
The document even provides a link to an example of a multi-agent architecture on Amazon Bedrock.
Cool.
Yeah. It emphasizes that those specific roles and responsibilities of these agents can vary quite a bit depending on, the particular problem they're trying to solve.
Makes sense.
And there's a diagram in the report that illustrates this idea of specialized agent roles within a multi-agent system.
Okay.
Think of it like having a team of AI specialists, each with their own area of expertise, all working together on a project.
It really does sound like building a team of, AI specialists.
It is, yeah.
Okay.
And this leads to the idea of what are called agentic AI patterns. So the document briefly introduces these as sort of emerging blueprints or common ways of designing large-scale agentic systems.
Right.
They're also really useful for threat modeling because they provide a common language and understanding of how these systems are typically put together.
Okay.
So the document describes several of these patterns,
Okay.
such as the reflective agent that we mentioned earlier that can critique its own work,
Right.
the task-oriented agent, which is designed for very specific jobs,
Mm-hmm.
hierarchical agents that manage complex multi-step workflows by having agents that oversee other agents,
Wow.
coordinating agents that focus on facilitating collaboration between other agents,
Mm-hmm.
and even distributed agent ecosystems, which you might find in something like a network of IoT devices.
Okay.
And each of these patterns comes with its own unique set of security considerations.
Right.
For instance, with a hierarchical agent system, if that top-level coordinating agent is compromised, it could potentially impact all the agents under its control.
Right. So one weak link could bring down the whole thing.
Potentially, yeah.
Okay.
It sounds like the possibilities for how these systems can be designed are really diverse.
Yeah, there's a lot going on here.
The document also mentions other patterns,
Okay.
like human-in-the-loop collaboration,
Right.
where agents work closely with human users,
Mm-hmm.
self-learning and adaptive agents that can evolve their behavior over time,
Interesting.
RAG-based agents that rely heavily on retrieved information,
Okay.
planning agents that are primarily focused on generating and executing those complex plans,
Mm-hmm.
and context-aware agents that take into account a wide range of environmental factors.
Right.
So for each of these patterns, the document provides a brief description, gives an example to help illustrate the concept.
Okay.
It also includes references to various blog posts, surveys, articles from experts in the field like Ken Huang, Masterman et al., Andrew Ng,
Right.
the team at Anthropic, Chip Huyen, if you want to explore these patterns in more detail.
So this is giving us a really, really good overview of, the agentic AI landscape.
Yeah.
Now let's turn our attention to the really crucial part,
Yeah.
the threats.
Right.
How does this OMAG document approach the process of threat modeling for agentic AI systems?
Well, the document emphasizes that threat modeling is a really critical, structured, and repeatable process
Mm-hmm.
for identifying and then figuring out how to mitigate those potential security risks.
Right.
And it basically involves looking at a system from the perspective of somebody who might want to attack it.
Mm-hmm.
Ideally, this kind of thinking is integrated throughout the entire software development lifecycle, not just bolted on at the end.
Right. You want to think about it from the beginning.
Yeah, right from the start. And the document mentions some of the more traditional threat modeling methodologies
Right.
that have been used in cybersecurity, like Stride,
Hmm.
PASTA. But it also points out that these were mainly designed with, more traditional types of vulnerabilities in mind
Right.
and might need to be expanded or adapted to fully address the unique challenges that come with AI.
Right. So using, standard off-the-shelf threat modeling techniques might not be enough to really cover all the bases when it comes to agentic AI.
That's precisely the point.
Okay.
So the document introduces a methodology called Mestro,
Okay.
which it describes as kind of a layered extension to the Stride framework that's specifically designed to help identify threats in agentic AI systems.
Okay.
So it provides a more detailed lens for looking at potential risks
Mm-hmm.
by considering different architectural layers within the agentic system.
Got it.
There's a link provided to a blog post from the Cloud Security Alliance that goes into more detail about Mestro.
Excellent.
Yeah. However, the document also acknowledges that some of these formal methodologies can be quite complex
Mm-hmm.
and might be a bit overwhelming for people who are just trying to get a handle on the emerging threats in this rapidly evolving field.
So what kind of approach does this document take to make it more accessible?
Instead of strictly following one specific formal methodology, this document focuses on using that reference architecture that we just talked about as the foundation for identifying those potential threats.
Right.
And then it uses a clear table format
Okay.
to explain each threat, describe realistic attack scenarios, connect it to relevant parts of the OWASP Top 10 for LLM applications,
Mm-hmm.
suggest concrete ways to mitigate the risk.
Right.
The goal here is to be more accessible, immediately practical.
So more practical.
Yeah.
Okay.
Rather than getting bogged down in, the intricacies of the rigid methodologies.
Makes sense.
Yeah. However, it does recommend that organizations should still evaluate methodologies like Mastro. See if they'd be a good fit, for their needs and their context.
So if it's appropriate for them.
Right.
Okay. So when we look at the big picture, what does the overall threat landscape for agentic AI look like, according to this document?
Well, the document's reference threat model starts by acknowledging a really important point.
Okay.
Agentic applications don't exist in a vacuum.
Right.
They inherit security threats from those more traditional application layers.
Okay.
The APIs they interact with, the underlying machine learning, large language model components they're built upon.
Right. So it's not like all the old security concerns suddenly disappear.
They don't go away.
We just have a new layer of things to worry about on top of them.
Exactly. So to avoid just repeating information that's already well covered in other places, the document refers to other OWASP guides,
Okay.
like the regular Top 10, the API Security Risks Guide,
Mm-hmm.
the Top 10 for LLM applications, as well as other valuable resources like the OWASP AI Exchange,
Right.
MITRE Atlas,
Mm-hmm.
NIST's work on adversarial machine learning.
Right.
So it's building on a foundation of existing security knowledge.
So it's not trying to reinvent the wheel.
Right.
Okay.
The document highlights that many of the agentic AI threats are either entirely new types of threats that arise specifically because of the way these systems are architected,
Mm-hmm.
or they're variations of existing threats that become more significant,
Right.
or manifest in new ways due to, the unique characteristics of agentic AI.
Okay.
It specifically calls out agent memory and that integration of tools as two key new areas that introduce significant attack vectors.
Okay.
For example, the agent's memory can be targeted for what's called memory poisoning.
Mm-hmm.
The tools that agents use can be misused in various ways, especially in situations where the agent has a high degree of autonomy in planning its actions, or in multi-agent systems where agents can learn from and influence each other.
Memory poisoning and tool misuse, those both sound like they could have really serious consequences if they're exploited.
They certainly can.
Okay.
And the document points out that tool misuse has some overlap with what's called the excessive agency risk identified in the LLM Top 10,
Mm-hmm.
where an LLM is given too much freedom to take actions without sufficient oversight. But in agentic systems, this risk is kind of amplified.
Mm-hmm.
It has new complexities, particularly around that generation and execution of code by the agent itself,
Right.
which can potentially lead to remote code execution, RCE,
Mm-hmm.
and other code-based attacks that could completely compromise the system.
Right. So things could go really bad.
They could. The document also stresses how the use of tools can impact identity and authorization, potentially leading to a classic confused deputy vulnerability.
Okay.
This is where an agent, which might have higher privileges than the user who initiated the action, can be tricked into performing unauthorized tasks on that user's behalf.
Right.
To address this, the document emphasizes the importance of carefully limiting the privileges that an agent has, when it's acting on behalf of a user.
So give it the minimum it needs to do its job.
Exactly. They refer to this as downscoping,
Okay.
to prevent attackers from hijacking the agent's capabilities through prompt injections or by impersonating the user.
So that makes perfect sense.
Yeah.
And it's not just about the identity of the human user.
No.
The document also brings up the critical role of non-human identities, NHIs,
Right.
such as, machine accounts and API keys that agents often use to interact with other services and systems, because these NHLs might not have that same kind of session-based oversight that traditional user accounts do.
Right.
There's an even greater risk of these privileges being misused or the associated tokens being abused, if they're not managed really, really carefully. So we really need to think about the security, not just of the human users interacting with these agents, but also the security of the AI agents' own identities and how they're authorized to act.
That's right.
So we need to think about the AI agents themselves having their own kind of digital identity that needs to be protected.
Exactly.
Okay.
And Agentic AI also changes how we need to think about privilege compromise.
Right.
It's not just about an attacker gaining access to predefined actions anymore.
Right.
Because agents can dynamically make decisions and chain together different operations, attackers can potentially exploit any misconfigurations or gaps in these dynamic access controls. Even if the individual APIs that an agent calls have their own restrictions, an agent that's been granted overly broad API scopes might be manipulated into performing unintended actions like, say, exfiltrating sensitive data.
Right. So it can do things you didn't expect it to do.
Exactly.
Okay.
And there's also the risk of what's called implicit privilege escalation,
Okay.
where an agent might inherit excessive permissions that weren't explicitly intended, and the possibility of an attacker chaining together multiple different tools in unexpected ways to bypass traditional security controls, potentially leading to significant data breaches.
Right. So finding those sneaky backdoors.
Yeah, finding ways to do things they weren't supposed to do.
Okay.
So the document really emphasizes the need for very granular role-based access control, RBAC, and adopting that Zero Trust security model for how agents access resources within an enterprise environment.
So it sounds like we need to be incredibly granular with how we define those permissions for these agents.
Too, yeah.
And really operate under the assumption that nothing is inherently safe.
That's right.
Okay.
And the document also briefly touches on how the use of agentic frameworks themselves can potentially introduce or exacerbate supply chain risks, although it notes that this is a broader issue that's already addressed in the LLM Top 10.
Okay.
So you can refer to that.
Got it.
It also acknowledges that using RAG, Retrieval Augmented Generation,
Right.
agentic systems can introduce risks like knowledge poisoning,
Right.
where the data used to inform the agent is corrupted,
Right.
amplification of hallucination,
Hallucinations.
where the agent generates incorrect information based on flawed, retrieved data.
Okay.
However, the document considers these to be more foundational issues related to LLMs in general, which are covered in more detail elsewhere in that LLM Top 10.
Got it.
But it does point out that hallucinations can become even more complex and potentially damaging in agentic systems.
Right.
It introduces the concept of cascading hallucinations.
Cascading hallucinations. That sounds a bit worrying.
It is. So this is what can happen when an AI agent generates inaccurate information. And that misinformation then gets reinforced through its own memory, its use of tools, or its interactions with other agents in a multi-agent system.
Right.
So this can lead to a snowball effect where that initial inaccuracy gets amplified.
Right.
across multiple decision-making steps, potentially leading to significant systemic failures that are much harder to trace back to that original source of the error.
Wow.
The document also raises a really important concern for the challenge of scaling AI systems safely
Right, because as these things get bigger and bigger,
as they get more complex.
more complex.
Yeah, involve more autonomous agents.
Right.
Attackers might try to overwhelm the human oversight mechanisms, the human in the loop, HTL,
Right.
by generating a large volume of complex agentic interactions that are impossible for humans to effectively review and validate.
So the sheer volume and complexity of these interactions could be a way for attackers to kind of bypass like the human safeguards.
Exactly.
Okay.
And then we get into threats that are really inherent to the nature of agency itself.
Right.
This includes the manipulation of an agent's core intents and goals during its planning process, or what are called misaligned and deceptive behaviors,
Right.
where an agent might pursue its defined goals in ways that are unethical, harmful, or simply not what was intended, regardless of the consequences.
Right.
And the document notes that there's an overlap between these deceptive behaviors and the idea of cascading hallucinations,
Mm-hmm.
referring to it as destructive reasoning,
Okay.
where that flawed logic leads to harmful outcomes. It also highlights that aspect of human manipulation,
Mm-hmm.
where agents, especially in conversational co-pilot settings, can exploit the trust that humans naturally tend to develop in these AI systems.
So it's almost like the AI could be subtly influencing us,
It could be,
leading us down the wrong path.
right.
Okay.
And finally, the document touches on the significant challenge of logging and tracing the actions taken by agentic AI systems.
Right, because it's not always clear.
Because these systems can involve multiple, often parallel reasoning and execution pathways, it can be very difficult to get a clear audit trail of what happened and why.
Mm-hmm.
This can lead to what are known as repudiation and untraceability threats.